All right, so this week in our support course, we're talking about Venn diagrams. And Venn diagrams, as we've already kind of seen in the parent class, and as you've probably just seen even prior to this class, are diagrams that show relationships between sets. So in my picture up here, I have three sets inside a larger set that we typically call a universal set, or even just a universe. And I'm using capital letters to denote those sets. So this circle here is A, this circle here is B, this one is C, and each of those three sets contains elements that look like lowercase letters. So you can see, for example, in the circle that A is representing, lowercase a, J, Z, K, B, and H all belong to that large circle right there. And then you'll notice also I have one lowercase letter out here, the letter I, and that is that is there to represent an element that's not in any of these three sets, but is still a part of the larger universal set. So what we want to do is use our set notation, our set operations that we've already talked about previous to this week, to think about how intersections, unions, set differences, complements, all of those things look when we're analyzing a Venn diagram. So let's just jump into the first example here. We want to write in roster notation. So remember, that's like the list within the curly brackets. This set here, the intersection of A and B and C. Notice they are all intersections here. Okay, so recall that intersections of two sets. So if you take an intersection of two sets, that's talking about, or that represents the set of all elements that both sets have in common. If we're taking an intersection of three sets, it's the same thing. We're looking for what all three sets in this Venn diagram have in common. And the way we can think about that is we look for the overlapping region between those three sets. Well, in my Venn diagram here, only this region in the middle is where all three of these circles overlap or intersect. And the only element in there is K. So I can say that the intersection of A, B, and C is this set right here. Notice that's in roster notation. We use curly brackets, and then we list all of the elements belonging to this set. There's only one in this case. Okay, so that one's not too difficult because there was only one region corresponding to this set. Let's take a look at a different example though. In this case, we want to look for the union of A and B, and then we want to take that and intersect it, or find the intersection of that set with set C. So we have both union and intersection appearing in this one set here. So let's start with the union since it's in parentheses. Remember, we do things in parentheses first. So remember that the union of two sets is a set that we get from taking everything in A, in this example, and B, and putting them into one larger set. So up here, A, remember, is this large circle here. B is this large circle here. So A union B is the set of all elements that belong to one of those two sets, at least one of those two sets. So that would include A, J, Z, G, F, E, K, B, H, all of those belong to A union B. That's a lot of elements. However, we have this additional operation here where we are also looking at just the intersection of that set that I listed out just now with C. So of all of those elements, we only want the ones that also belong to C. And I can see here that that would only include elements B, K, and E. That would be my set that I want to write out here. Okay, you'll notice as we work through these problems, there's not like work to show. There might be a way that I could do this so that I am showing a lot of work, but I'm just kind of looking at the Venn diagram and talking my way through it until I can determine what elements belong to the set that we're talking about. So let's try something else. Here we have A union B, which also appeared here. Remember, and we listed off what all of those were, but this time I'm taking the complement of that set, and then I'm going to take the union of whatever that is with C. So this looks similar to this one, except I'm taking a complement here, and then I have a union here instead of an intersection here. So let's think through what that would look like. We listed off everything in A union B. Remember, it was all of these elements here just everything that belongs to either A or B or potentially both. So the complement is the set of everything else. That would be the set of all elements that are outside of both of those sets, which from what I can see here only includes I, D, and C. Okay, so because we're going to take that and then form a union of that set, I, D, and C, with the set C, unions look for not just what's in common between two sets, but they throw everything from here and from here into the same set. So that means I, D, and C are going to still be in this union. I may as well just list them now. But then if I look at the union of that with C, here's the circle representing set C. And we've already accounted for a couple of the elements that are in that set, but everything else that's in C should also get thrown into this union down here. So we have not included B, K, and E, and those need to show up as well. B, K, E. That's what this set would look like. Notice I have everything that's in the complement of A union B, as well as any other elements that we hadn't listed yet that belong to C as well. Okay? All right, last one. Here, this is a set difference. And remember, what this means is, first we have in parentheses here, B intersection, or the intersection of B and C. So we'll figure out what's in there. And then A minus that is saying that we want a set that contains everything that is in A, but is not in this set here. So first, let's figure out what B intersection C looks like. Here is my set B. Here is my set C, and the two sets intersect right here. So their intersection contains K and it contains E, okay? That's just the thing in parentheses. Now, if I want to take the set difference, A minus that, then essentially what I'm doing is I'm taking the entire set A, and that minus there is telling me to remove any elements in A that also belong to this set B intersect C. So remember, the intersection of B with C was this set. It had K and E in it. E is not in A, so we're going to just disregard it completely. K does belong to the set A, and the set difference says to throw that out. So now what we're left with is the set A, but after removing this element K, which is going to look like the set containing A, H, J, B, Z. That's the set of everything in A except for K. Okay? So this is the idea behind what you're doing in the worksheet for this week. You're going to be given a Venn diagram, kind of similar to what you see here, and you're going to be determining which elements belong to these different sets that come from the Venn diagram itself. Okay? So that's what we're doing this week.